All right, today, circumference and area of circles. We're also going to talk about all the various parts of circles along the way. Before we actually get into anything, when we have lessons, sometimes I like to pull in something about a lesson from a movie or sometimes a job-related video. Today's is from a movie. And so, just kind of pay attention to this. Let me get my volume up here first.
We're trying to crack the combination of this tab that's there, and the writing here says we'll...
So before we even get into pi and how we find pi and what we use it for and all of those things, we're going to do a little bit of review and then add on to the things. So in earlier grades, you spent a lot of time talking about perimeter. And I know I have perimeter formula there. I don't really like to think of things in terms of perimeter formula. The reality is if you have a shape with sides, to find the perimeter, you add up all the sides. You find the sum of all the sides. So it doesn't matter whether it's a rectangle or a triangle or a parallelogram or a trapezoid, you still are adding up all of the sides. And this is the point where you're supposed to be filling in some stuff in your notes. But then we have this idea of a circle. And even though when we're finding the distance around a circle, we are technically finding the perimeter of a circle. But since there aren't any sides, we have a different name for that, and that would be the circumference of a circle. And there is a formula for that, and it is the circumference is equal to pi times the diameter. And the diameter of a circle is the distance all the way across the circle through the center. And there will come a time a little bit later, and somebody in the period will say, well, yeah, but couldn't you use also 2 times the radius times pi? And the answer to that is yes. And we'll talk about and see how the diameter and radius are related in a few minutes. All right, so that's the distance around shapes. The area of shapes, now we do actually have formulas. To find the area of a rectangle, of course, it's the base times the height. And this is where we should be filling in things again. To find the area of a triangle, it's the base times height, half of that. And the reason is because depending on how the triangle looks, a triangle is either half of a rectangle or it's half of a parallelogram or perhaps half of something else. A trapezoid is area is equal to the sum of the parallel sides or the sum of the bases times the height and take half of that. And the reason is because a trapezoid is essentially half of a parallelogram. Or it could be half of a rectangle as well. And then we have a circle. Well, for a circle, the typical area formula is pi times the radius squared. And the radius is the distance from the center of the circle out to the edge. And if the diameter is all the way across, it takes 2 radiuses to make a diameter. And once again, we will come back to that idea. So since our new focus for today is circles, let's go into a little bit more detail on what a circle is and various parts of a circle. And before we do that, the standard we're talking about today is 7.g.4, and that is where we're supposed to know the formulas for the area and circumference of a circle, which is what I just gave you, and basically to use that to solve problems, and then also to give an informal derivation of the relationship between the two, and that's part of what today is all about. So a circle is where we have a center with an infinite number of points surrounding that center. And so that's where the definition comes from. The set of infinite points equidistant, so the same distance from the center. In this case, the center is 0. So parts of a circle. The circles are usually named by their center. And since the center is O, that's how we name the circle. This is circle O because the center is O. And then if I created a point on the edge of the circle, A, that would be the radius. Radius OA, because the radius is from the center of the circle to the edge. So it's a segment or distance from the center to the circle. And once again, this is where we should be filling in some of the blank areas. And if I create a new point here, X, and M, and I connect those two together, that is actually called a chord. So that line segment XM is a chord, and a chord is a segment that connects one point on the circle to another. And it's C-H-O-R-D. And then if I create another point on my circle Y, connect from X to Y, since that goes through the center and touches the outside or the edge of the circle, that would be a diameter. So the diameter in this picture is XY, and that's a chord that passes through the center. And a diameter is a chord because it does connect to the circle at two different spots there, two different edges. And then some other pieces. If we have an angle that's created at the center of the circle, like I just notated right there, so that would be angle XOA. We call that the central angle. So that's, that would be an angle at the center of the circle, or an angle whose vertex is the center. And then we have parts of the outside of a circle. So that part right there that I just connected from X to A, that is called an arc. So that would be arc XCA. An arc is a piece of a circle, or part of a circle. If you thought about that in terms of distance, it would not be the distance all the way around, just part of the way around. Here's another arc right here, XMY. And that arc is, contains half of the circle, which is sometimes called a semicircle. Once again, semicircle can be thought of as half of a circle. All right, so those are all the parts of a circle that I wanted to talk about, but now we need to relate the radius and the diameter. So as I already mentioned, the circumference of a circle is the distance all the way around a circle. So the yellow part is the distance all the way around that circle. The relationship between the diameter and the radius, well, the diameter is twice as long as the radius. And the flip of that is the radius is half as long as the diameter. So in terms of that picture right there, the diameter is all the way across through the center, but the radius is from the edge to the center. So as you can see, it takes two radiuses, or two radii is usually how we pronounce the plural of a radius, two radii to make one diameter. Or half of a diameter to make a radius. And I'm going to stop for about a minute to let people get caught up. Okay, so our focus from here on out is dealing with problems that involve circumference, which is the distance around a circle, or the area of a circle, which is basically the measurement of all of the interior part of the circle. All right, so before we actually get into any of that, we got to talk about where pi comes from, okay? So the relationship between the diameter of a circle. So if I take a standard silver dollar and I can measure the diameter of that, which happens to be 38.1 millimeters, and then measure the distance all the way around that silver dollar, which is 119.7 millimeters, rounded to the tenths place, and I compare that ratio of the circumference to the diameter, in other words, 119.7 divided by 38.1, we get approximately 3.1417. And if I continue to take circular objects and continue to increase the size of them, a DVD is bigger in size than a silver dollar, and if I compare the circumference to the diameter, much like I just did, I would get 3.1416 approximately. And I noticed some of you were looking in the back, because in the back of the room is approximately 70 digits of pi. And if you look, you should notice that the bigger the object, the closer that we get to that estimate of what pi really is. So if I take this tabletop, that's approximately 3.1415, and so on. And so, regardless of the size of the circle, the ratio of the circumference to the diameter remains constant. And that constant happens to be what pi actually is. Okay? And we usually use 3.14 as the approximation of that. So if I take that ratio of c over d equals pi, and if I were to take that, and if I were to multiply both sides of that by d, or in other words, solve that equation for c, I get the circumference formula. And that's basically where it comes from. So if I want to find the circumference of a circle that has a diameter of 7, the circumference of a circle is found by multiplying pi, which we're going to use the numeric value of 3.14, times the diameter, which in this case is 7. That would give me something that looks like this. Now, one thing that you haven't seen before is something that we sometimes refer to as in terms of pi. So if I ask you on X problem worksheets from here on, if I ask you to leave something in terms of pi, what that means is just leave pi as pi. So this circumference in terms of pi is just 7 pi. Now if I ask you to write this in terms of a decimal, then you would actually have to write 3.14 in place of pi and then multiply that out, and we would get the decimal value would be 21.98 inches. Okay? So if I tell you leave it in terms of pi, this is what we want to leave it as. And you should be happy when I only ask you to leave it in terms of pi because you don't have to do any multiplying. It's when I tell you to find the decimal value that you actually have to replace pi with 3.14 and multiply that out. And we're going to do a little bit of practice of both today. Okay? All right. Number 1. We're supposed to find the diameter and the circumference. So we're going to do number 1 and number 2 together. I'm telling you that the radius is 5 inches. What's the diameter? Just tell me, please. 10 inches. All right. So if the radius is 5 inches, the distance all the way across is 10 inches. So that means the diameter is 10 inches. And we need the diameter to find the circumference. And so the circumference, of course, is pi times the diameter. Could somebody tell me what the circumference would be in terms of pi? And that should take about 1 second, right? What is it in terms of pi?
10 pi.
It's 10 pi. Why? Because the diameter is 10, and if I tell you in terms of pi, we can leave pi as pi. And I know that seems weird, but sometimes that's all we have to do. So the area of that in terms of pi is 10 pi. Now if I tell you to find the decimal value, you would have to replace pi with 3.14 and multiply that out. And 3.14 times pi is 31.4. So the circumference is approximately 31.4 inches. Now, anybody know why I'm using the approximate symbol there instead of equals?
Because that's not the exact value of pi.
That's not the exact value of pi, right? That's just a pi to the hundredths place is really what that is. And much like perimeter, units for circumference is just the units. Inches, feet, yards, miles, whatever that happens to be. Okay? All right, let's go to number 2. This one I think I want you to fill in all the blank areas. Okay, number 2, if the diameter is 8 meters, which is all the way across the circle, that would of course mean the radius is half that distance, or 4 meters. In order to find the circumference, we do need the diameter though, so it's going to be pi times 8, or in terms of pi would be 8 pi. But as a decimal, we replace pi with its decimal approximation, which is 3.14, and that would give us a circumference of 25.12 meters. Okay? Let's go to number 3. Number 3, it says, this circular section of lawn needs to be surrounded with a flexible fence. What is the length of the fence that will be installed? And I'm going to tell you that the radius of that circular section of lawn is 7 yards. So find how long the fence would need to be to go all the way around that circular section of lawn. All right, so in order to find the length of the fence that would go all the way around that circular section of lawn, we need the diameter. And of course the diameter, if the radius is 7, is 14. So in terms of pi, that would be 14 pi, but that doesn't make a lot of sense in a real world problem like this one. We would need to find the decimal value. And so we would need approximately 43.96 yards of feet to go all the way around that. And in situations like that, you probably would round it to 44 yards, but we're going to leave it like that for this. Okay? All right, so that's circumference or distance around a circle. All right, so let me pause this if I can. I don't even know if I can. Hold on a second. Let me back up here before I hit that. This is basically sort of an informal little video that shows you one way of showing you the relationship between the circumference of a circle and its area. So just sort of look, and I'll try and talk about things. I thought I could stop it, but apparently I can't. So we're going to take the circle, and we're going to straighten out the circumference of that circle. And then what I'm going to do is I'm going to take that circle, and I'm going to break it apart into, if you want to think about it in terms of a piece of pie, we're going to break it apart and then fold it in half like that. Now, those are pretty big pieces of pie, but if I take and keep making those pieces of pie smaller and smaller and smaller and smaller, it looks to me like that gets very, very close to a rectangle, where the height of that rectangle is actually the radius of the circle, and the base of that rectangle, as I'm waiting for it to bring it up, is pi times the radius. Now, there's usually a question of, well, where did this come from? Well, remember that this part right here was half of the circle, and this part right here was the other half of a circle in terms of its distance around. If the distance around a full circle is pi times the diameter, and the radius is half of the diameter, that's essentially where this pi radius comes from, where a pi radius is half of a circle and the other pi radius is the other half of the circle. And so if we find the area of that rectangle, pi radius times radius, well, radius times radius is radius to the second power, and so that's an informal derivation of how we get pi r squared for the area of a circle, creating very, very small pieces, slivers of pi, if you want to think of it that way, turning that thing into a rectangle, and then going about it that way. Okay? And this is just another way of looking at it. Taking the circle, breaking it apart into pieces of pi, trying to get that thing as close to a rectangle as we can, and that's one way of coming up with the area of a circle formula. Pi times the radius squared. So in order to find the area of a circle, we don't need the diameter, we need the radius. So if I tell you that the diameter is 8 yards, what is the radius?
4.
It's 4 yards. Okay? And so we now have the information that we need to find the area of a circle. So the area of a circle is pi times the radius squared. 4 squared is 16. So that means in terms of pi, the area is 16 pi. Once again, because 4 squared is pi. Now, if I asked you to find the decimal value, you would replace pi with its decimal approximation of 3.14. And when we multiply that out, we get 50.24 square yards. And just like with rectangles and triangles and trapezoids, units for area will always be the units squared. So that's why it's square yards for the units. Okay? Now, what if you were asked to find the circumference? Well, sometimes you have to work backwards, but we already know that the diameter is 8, so in terms of pi, that would be 8 pi, and then of course, to find the decimal equivalent to that, it would be 25.12 yards. So sometimes we might be asked to find the area and find the circumference from that. Okay? All right, number 5, you are asked to once again find the area based on information that I have given you. So everybody try number 5. In number 5, I'm telling you that the radius is 7 yards in case we need it. The diameter is 14 yards. To find the area, we don't need it, but I also did ask a question about circumference, so we kind of do need it. So if the radius is 7, and the area of a circle is pi times the radius squared, to find the area, it's pi times 7 squared. 7 squared is 49. And so in terms of pi, it would be 49 pi. But if we need the decimal value, 49 times 3.14 is 153.86 So that makes the area approximately 153.86 square yards. To find the circumference, of course, pi times the diameter, and that's 14 pi in terms of pi, and as a decimal, 14 times 3.14 is 43.96. So the circumference is approximately 43.96 yards. All right, so let's go to an application problem. Number 6. This is a picture of a fountain on the south lawn of the White House. The bottom of the fountain needs to be repainted. If the diameter of the fountain is 100 feet, what is the area of the section that needs to be repainted? Go ahead and try that one. We know the diameter of that circle is 100 feet, but I don't need diameter to find area. I need radius. And the radius happens to be 50 feet. It's the distance from the center out to the edge. And so 50 squared is 2,500. And 2,500 times 3.14 is 7,850 square feet. 7,850. All right, let's go to number 7. Number 7, I am giving you that the area of a circle is 36 pi square feet. What is the circumference? I want you to talk about that one with your shoulder partner and how you're going to go about trying to find it. So if we know that the area is 36 pi, and to find the area of a circle, it's pi times the radius squared, we know that the radius squared is 36, and so that means that essentially the radius of that is going to be, and I'm going about that mathematically, even though you should be able to do that in your head, the radius is 6. And since I know the radius is 6, that means the diameter is 12, and so here is where you could replace diameter with 2r, because it takes 2 r's or 2 radiuses to make a diameter. But regardless of that, if you know the radius is 6, you should know that the diameter is 12. So the circumference is pi times the diameter. That is 12 pi. And in terms of a decimal, that would be 37.68 feet. All right, so number 8 is very similar to number 7. Go ahead and try number 8 very quickly. All right, in number 8, a circle has an area of 49 pi feet squared. What is the circumference? So if the area is 49 pi, that means the radius has to be 7, because 7 times 7 is 49. And if we know that the radius is 7, that means that we then know that the diameter is, of course, 14. And that number is seeming familiar, like we've done that, maybe a problem already with those numbers in there. Yeah. Yeah, okay. And so if we know the radius is 7, we know the diameter is 14, and pi times 14 is 43.96 feet. Okay, last idea for today. Number 9, an artist used silver wire to make a square that has a perimeter of 60 inches. So that square that's surrounding that circle, it has a perimeter of 60 inches. She then used copper wire to make the largest circle that could fit in the square, as shown below. The question is, how many more inches of silver wire did the artist use compared to the copper wire? Remember, the silver wire is the square, the copper wire is the circle. So the first thing that we need is we need some information here. Well, if I know that the perimeter of that square is 60, what would each side of that square be? Yeah, that's not a trick question. The square has all equal sides, right? So we're trying to figure out 15, 15, 15, and 15 makes 60, or if you think about it, all the sides are equal, 4 sides, and if we divided 60 by 4, we would get 15. Well, if a side of the square is 15, and this is probably where you should be taking very good notes here, if a side of a square is 15, that also happens to be the diameter of that circle, right? It's the distance all the way across. So if a side of a square is 15, the diameter is also 15. Well, that's a valuable piece of information here. And in this problem, we're not dealing with area, we're dealing with distance around. And we're trying to figure out how much more silver wire the artist used than copper wire. Well, we already know that the artist used 60 inches of silver wire. The copper wire would be found by finding the circumference of that circle. So the circumference of that circle is 15, which is the diameter, times pi, and that's 47.1. So 60 inches of silver wire, 47.1 inches of copper wire. That means she used 12.9 more inches of the silver wire than the copper wire. Okay? Number 10 is very similar to number 9. Everybody try number 10. As I walked around, most of you had no problems with this problem. It is very similar to number 9. We know that the perimeter of the square is 20, so that means each side of the square has to be 5. Well, if the side of the square is 5, that also means the diameter of that circle has to be 5. And we're needing to know how much more silver wire they used than the copper wire. Well, they used 20 inches of the silver wire. The copper wire is the circumference of that circle, which is 15.7. So that means they used 4.3 more inches of the silver than of the copper. Okay? We are finished.